This is still on the topic of water, and this is lesson 11. What is solubility and how does it change with temperature? We're going to look at pages 39 to 44. First of all, you need to know the meanings of the following words. So you've got solubility, solution, solvent, insoluble, solute and soluble, and we're going to look at what affects solubility. If you look at this diagram, you're starting with a solid, so that could be something like sugar or salt. You've then got a beaker of liquid. Easiest thing to think about is water. And then you end up with a solution. Now, which is the solvent and which is the solute? You're going back to your 7 work now. So the liquid is the solvent and the solid is the solute. You've then got 3 pictures. You've got seawater, you've got salt, you've got water. Decide which is the solute, the solvent or the solution. You may want to pause this voiceover now to give yourself a chance to have a think, so you can stop and start it. Another 4 pictures now. You've got milk, you've got chocolate milkshake, you've got cocoa powder and you've got sugar. Which is the solute, the solvent or the solution? Now you might have 2 of one of these now, and I'll give you a clue. You've got 2 solutes there. You've then got this in your book on page 39. What is solubility? What affects it? But we need to know the words first. Now to fill in that information, if you use this screen, you can go back and fill in the correct words with the description. The words here are not in order with the boxes, so you have to sort them out first and then write them in the correct box. So this screen does not give you the correct answers. It gives you the answers to each of the words, but in the wrong order. So you have to sort those out. Now, measuring the solubility of substances. So we're going to look at how much substance dissolves in water. So if I go through it with you, you've got a boiling tube, you've got some solute, you've got some solid, you've got a balance there to weigh things, you've got a filter funnel, you've got another balance there. Now it says measure 10 centimetre cubed of water and pour into a test tube. It can be a test tube or a boiling tube, it doesn't matter. Record the mass of sodium chloride. So we're going to look at sodium chloride first and add a spatula of sodium chloride to the water. Shake 40 times. If dissolved, add another spatula and do the same. Keep adding until no more will dissolve in that water, and then you re-record the mass of sodium chloride. And then you can calculate how much sodium chloride has dissolved in 10 centimetre cubed of water. So we're going to make a saturated solution. Now a saturated solution cannot dissolve anymore. So what we're going to do is we're going to add the sodium chloride to the water until no more will dissolve. And we'll see the crystals at the bottom. Look, can you see that? The nearest boiling tube there, you can see the crystals, they're no longer dissolving. So this is our table. You've got the substance, sodium chloride, ignore potassium nitrate for a minute. You've got the mass at the start in grams, you've got the mass at the end in grams, and you've got the mass dissolved in grams per 10 centimetre cubed of water, because that's the amount of water we're using. We're going to look at 20 degrees C water first. So if we look at this photograph, you've got a balance there with a plastic dish on it, and you've got sodium chloride in there. You've got a beaker labelled 20 degrees C with a test tube in there. It's a test tube we're going to use there, and a stopper. And you've got 10 centimetre cube of water in a measuring cylinder. You've also got a spatula because you're going to need to add the salt to the water. You've got a thermometer because we know that that water is at 20 degrees, so we've checked it with a thermometer. So we're going to pour the 10 centimetre cubed of water into the test tube, and then we're going to add the sodium chloride, shake it 40 times after each spatula to make sure it dissolves. Once it stops dissolving, we're going to reweigh it. So what we've done, and you can see in the test tube, you can see no more is dissolving now. We've got a little bit left over that hasn't dissolved, and you can see the mass on the balance. Okay, so that's how much has been put into the water. So your table now should look, ignore this bit up here because that's off my screen, I've just taken a photograph of it. You should have 12.01, that was the mass at the start. Mass at the end is 8.95, so you can work out the mass dissolved. It's 12.01 take away 8.95. Now we're going to do exactly the same for potassium nitrate. There's your starting mass for potassium nitrate, again at 20 degrees. We're going to dissolve it in 10 centimetre cubed of water, and that's how much we're left with. Again, you can stop and start this video. Voiceover. And that's what you should be putting into your table, and you can work out the mass dissolved for each one. Now you're going to repeat the whole process for 60 degrees C. You haven't got a table drawn, but you can draw it into your book. So you're going to do this at the bottom of page 41. You draw the table out exactly the same as the previous table, and the substances are going to be the same as well. And we work through the next few slides and you can fill in your table. So we're going to start with the same mass of sodium chloride at the start, but this time we're using the right hand side beaker, the 60 degree C, and so the water in the measuring cylinder will be 60 degrees. That's your final mass. That's your starting mass of potassium nitrate. That's your final mass of potassium nitrate. So you fill in your table, you work out the mass dissolved, and you answer the question, what happens to each chemical's solubilities as the temperature increases? In other words, do they dissolve more at higher temperatures, or do they dissolve less at higher temperatures? Now, solubility is a measure of how much mass you've dissolved in 100 centimetre cubed of water. That's the standard measurement. It can either be written as 100 centimetre cubed or 100 grams of water. That's how you see it written, but we've only dissolved ours in 10 centimetre cubed. Now, this is a solubility curve that tells us how many grams of a substance dissolves in 100 centimetre cubed or 100 grams of water at different temperatures. And you can see as the temperature increases, you can see the lines for potassium nitrate and sodium chloride. This is potassium nitrate, this is sodium chloride. And you should be able to see that they're both increasing. Sodium chloride increases a lot less than potassium nitrate. That's a massive increase in potassium nitrate. But even so, the sodium chloride is increasing as well. So they get more soluble. You can dissolve more of them in higher temperatures. You've got this then in your book. I'm going to give you some results. The following results can be used as a standard set. Compare these results with the solubility curves on the previous page. So I want you to work out how much sodium chloride and potassium nitrate is dissolved in 10 centimetre cubed of water, like we've just done. And you write that in there. And then you write the solubility, look, of sodium chloride in grams per 100 centimetre cubed of water now. So you use these values here, but this time you've got to convert them to 100 centimetre cubed. So you times them by 10 because you dissolved them in 10 centimetre cubed of water, but now we're looking at 100 centimetre cubed of water. Then you use the graph. So you use this graph that you've got in your book to work out the actual solubility of sodium chloride and potassium nitrate. And so on the graph, what you do is you go across to 20, draw a line up. You can use that with a pencil and ruler, read across. Draw a line up and read across. And you will get values, and I want you to work out whether the values from the table are higher or lower than the actual values. And then I want you to do exactly the same for 60 degrees. But my mistake, can you please change the value mass at end for sodium chloride to 58 grams, not 57 grams. And you do exactly the same. So you work out these values, then times them by 10 for those, and then you work out the actual solubility from the graph. And this time on the graph, we'll be going up to 60 and drawing a line up to each curve and reading off the solubility. But please change that mistake. Oh, look, I've even given you an answer for 20 degrees now, so at least you can see whether you're doing it right. So if you check your answers, these are your values, 4.3, 4.0, times them by 10, and then these values I've got from the graph. So check how I've got those from the graph. And my values, which are these from the table, are higher than the actual values. This could be due to because too much substance was added. Not all the substance dissolved. Some was left at the bottom, some stuck to the top of the test tube. So you've added a bit too much. And I know that sentence doesn't read very well, but this could be due to too much substance being added would be better. So we'll work in from that graph, and I want you to complete the answers for page 44. Remember to change the mass at the end for sodium chloride to 58, not 57. And I've given you a summary of what you need to do.